What we're going to do now is we're going to talk about the real purpose for matrices as far as we're concerned. What we're going to do is we're going to solve multiple equations with multiple unknowns. What we're talking about here is three equations with three variables, x, y, z. Now what we're going to do is we're going to take that and put it into a form that is more useful in the calculator, and that's in the form of a matrix. Now this is an augmented matrix because you have the coefficient matrix, you have the answer matrix. They're put together in one augmented matrix, one large matrix. Now what we're going to do is we're actually going to put it together in a calculator. So anytime we want to put in a matrix, we're going to go second matrix. And from that matrix, we're going to go to edit, and A would be just fine. So we need its size. Now its matrix size is going to be 3, enter 4. Just happens to be something that's already in here. If we put our augmented matrix in, we simply type in -1, enter, 8, enter, -2, enter, -37, enter, 2, enter, 5, enter, -11, enter, 7, -7, enter, 4, enter, and finish putting in the matrix. Once the matrix is put in, you go second, quit. Now, using an augmented matrix, the easiest thing to do is use reduced row echelon form, or RREF. RREF. So to do that on a calculator, I'm going to go to second, matrix, slide over to math, go down to RREF, hit enter. Now I have to tell it what to do, so do it on what? Well, let's go to second matrix, and under names we'll click A, hit enter. And it gives us the identity matrix 1 0 0 0 1 0 0 0 1, and it gives us a row. That final row allows us to say that 1x is going to equal -5, 1y equals -6, 1z equals -3. Because the 1 in the first column is in the x position, so that's -5. The 1 in the y column goes with -6, etc. Very, very quick, very, very easy, but you have to have the technology to do it. The other way I'm going to show you is in the next piece. We're going to use the same problem, but now we're going to use the inverse method. Using an inverse of a matrix. To do that, we're going to actually split this one system of equations into three matrices. One involving coefficients, one involving variables, and one involving the answers. By the way, the reason the variables are vertically listed is because I have a 3 by 3 matrix here, so the next matrix, if I'm going to multiply, must be a 3 by something, in this case a 3 by 1, giving us a 3 by 1 matrix. Now, we're going to again have to use our calculator, but in this case, we're going to need two different matrices. So we're going to say second, matrix, edit, matrix B. This one is going to be a 3 by 3, and we're going to put in -1, 8, -2, 2, 5, negative 11, 4, negative 7, and 6. Hopefully all those are correct. Second quit. Second matrix again. Let's go ahead and edit C. In this case, we're going to be a 3 by 1. And that's going to be made of negative 37, negative 7, and 4. Make sure you hit enter, otherwise it won't lock it in. Now, to do this, I in essence need to divide by an entire matrix, but I can't divide by a matrix. So whereas this was B, this was C, I'm going to multiply by B inverse. That will undo B, but if I do it to one side, I must do it to the other. And you'll notice I put it first, so again I have a 3 by 3 and a 3 by 1. We have to put it in the correct order so that the centers match. Now, using the calculator, I simply say second matrix, and we'll get B. To make the inverse, simply go to the x to the negative first button, so the one that says matrix otherwise on it, times second matrix C. And when you have this form in, and hit enter, you get negative 5, negative 6, negative 3, which should and does match our other set of answers. So the final answer matrix gives us the same result. Those are using matrices to solve multiple equations with multiple unknowns. Your homework for this section is to do the following problem using both the reduced row echelon form and inverse matrices, which means you will do it twice, the same problem, two different methods showing both the augmented matrix, the inverse matrix setup, and then the final answer for both. So one problem, two different methods, so you'll have one answer twice. That also needs to be turned in.